In this tutorial we're going to look at rationalizing the denominator. This is a technique that we use a great deal, not only to do with numerical fractions but with algebraic fractions, and you'll see it sometime later in the course also with complex numbers. So this idea is very, very important. So let's have a look at this first example. Care must always be taken to ensure that you do your algebra correctly. So here we rationalize the denominator by again creating the difference of two squares. And whatever we do to the bottom, we must also do to the top. So this trick that we've learnt in the previous tutorial, adding and subtracting fractions, is very, very common and quite powerful. So now we can see that the denominator becomes the difference of two squares, where we say this squared minus this whole thing squared. And when you square everything here, you have to square the 3 as well as squaring the root 5. That gives us 9 times 5, which is 45. So on the top you've got minus 5 plus 5 plus 3 root 5. This now becomes minus 20 in the denominator, minus 5 plus 3 root 5. You have to be able to see that these two numbers here cancel. The two minuses ensure that it's a plus, and the 5 cancels with the 20 to give you a 4 in the denominator. So your final answer is 5 plus 3 root 5 over 4. Let's now do the same thing, but this time we'll use letters instead of numbers. So now we will take minus a divided by a minus a root 2. There are various ways of approaching this problem. I would always favour trying to cancel as soon as possible. And what you would notice is that in the denominator, a is here and a is there. This allows us to factorize the a outside. So we ensure that a times 1 is a times root 2 is a root 2. And in the numerator we still have minus a. So now we do our usual technique of multiplying top and bottom by something that makes the denominator look like the difference of two squares. Here we are allowed to cancel the a's. We still have that minus sign there. So in the numerator we have minus 1 plus root 2, and in the denominator we have the difference of two squares. That means 1 squared minus root 2 squared, which is 1 minus 2. So you can see that this is minus 1, and that minus 1 and that minus cancel. So we effectively get 1 plus root 2 as the answer. So whether you want to see it as this, minus 1 plus root 2 divided by minus 1, and so the two minuses cancel, but again you've got to be able to sort of see through that and try to make the question look fairly easy.